Okay, so in terms of subcortical structures, they contribute rather mightily to our experiences and our behavior as well as these cortical networks that we kind of, broadly described, dependent as being dependent on networks in the cortex, right? But the subcortical networks, remember, subcortical again means below the level of the cortex, but these are going to also be gray matter, kind of nuclei, right? They're going to be clumps of neurons that are, interconnected with each other and have, the cell bodies and the dendrites and the axon terminals, all the synaptic connections. Like you also find, up in the gray matter of the cortex, you're going to find clumps of gray matter that are, connected via white matter projections, right? To each other. These subcortical structures are sometimes networked together, but they're also rather heavily interconnected sometimes with the cortex as well. So let's look at a couple of these. So one, there's a great big, set of important nuclei that we find, within the structure at the sort of base of the cerebrum called the brainstem. And I'm going to come a little closer here and try to show you the brainstem. I've taken the cerebellum off the back so you can sort of see this a little bit better. Here's the cerebrum, right? Here's the frontal lobe. Here are the temporal lobes, right? Here. And then this is the brainstem right here. And again, it's symmetrical. There's a left and right brainstem. And I want you to think about the brainstem as having like a lot of important nuclei, gray matter nuclei that are essential for sort of maintaining the body. There's a lot of autonomic nuclei that are involved in, maintaining heart rate or, breathing rate, etc. There are also nuclei that are involved in sort of direct motor output to the body and the face, right? So for facial expressions, like if somebody shows you something gross or something, you have a really quick kind of facial response. Like if you, for example, walk out into a spider web, you'll have this kind of, bodily postural adjustment and facial expression adjustment that are quite rapid and mediated by nuclei that are located at the level of the brain stem. Freezing behavior that's associated with fight or flight, right? Sympathetic activation. Orienting behavior, which is also associated with that, with the detection of something novel or unexpected or potentially threatening. So a lot of nuclei are involved in direct kind of, motor output, to generate rapid changes in the body, both viscerally, but also in facial expression and postural adjustment. And also there's a tremendous number of nuclei that are located, there are nuclei located in the brainstem that are involved in modulating our level of alertness, like how aroused or awake are we at any one time. When I have this caffeine, actually one of the places that it acts is in the brainstem to help enhance activity in some nuclei that send their white matter projections into the cortex, all around the cortex, to kind of alert or arouse or wake you up, get those networks to better, collaborate and, engage in decision making and memory and all these other aspects of our psychology. So alertness is a really critical component. When you start to get tired or drowsy or drift off and go to sleep, these specific nuclei that are found in the brainstem reduce their level of activity, and they, help the cortex kind of, it's less effective at, collaborating, and ultimately you can, go to sleep. There are nuclei that are involved in sensory processing. We'll see, like for your ears, for example, there's a lot of nuclei that work their way up the brainstem. Your tongue, the taste information and touch information, they're going to come in through the brainstem. They're going to be nuclei in the brainstem that are really essential for, initial processing of a lot of sensory information, somatosensory information from the body. And then finally, there's, in addition to the gray matter, all these subcortical networks and nuclei that we're describing in the brainstem that are so essential for keeping us, in good shape, viscerally. There are also significant white matter tracks, so cables, lots and lots of, myelinated axons, some unmyelinated, but lots of axons. So there's lots of afferent information working its way from the body up through the brainstem to maps in the cerebrum, right, or to other subcortical structures in the brain. And then there's also plenty of motor output, lots coming from the frontal lobe, for example, working their way down through the brainstem and then into the spinal cord to generate a lot of these sort of voluntary movements. So the brainstem is a really important, component, part of the brain. It contains a lot of absolutely essential nuclei and tracks that let you, become aware of what's going on, effect change on your body and thus on your environment, and also, generate a lot of, autonomic and sort of visceral and, reflexive behavioral responses, many of which serve, like facial expression changes, postural adjustments, as social signals, right, as stimuli to others about, what you're experiencing, or what may be going on sort of